Wave basics. How do we describe a wave? Throughout this lesson, we'll be able to describe a wave in terms of transverse, longitudinal, traveling, or standing, mechanical, or electromagnetic. We'll represent a wave in various ways. We'll be able to describe a wave in terms of its wavelength, frequency, period, and wave speed. We'll describe how the intensity of a wave depends on the distance it has propagated. Some vocabulary we'll need to know. Remember, this is not the entire lesson. This is just so you know what I'm talking about as we go through this lesson. Starting with a wave is a disturbance in a medium. A medium is just a region of matter. Could be air, could be water, could be a vacuum, if there is no medium, that travels through the medium in all directions. Wave pulse is a single disturbance, while a continuous wave or a periodic wave is a series of disturbances that have regular timing. Propagation is the way that the wave travels, carrying energy without carrying matter. We have transverse wave, which is a type of wave where the particles of the wave move in directions that are perpendicular to the direction the wave itself travels. A crest is the high point of a transverse wave. A trough is the low point of a transverse wave. Longitudinal wave is a type of wave where all of the particles of the wave move in directions that are parallel to the direction the wave itself moves. Compression, the point in a longitudinal wave where the particles are clustered close together. Rarefaction, or expansion, is the point in a longitudinal wave where the particles are spread far apart. Traveling wave is a wave where the crests, or troughs, or compressions, or rarefactions travel from one point to another. Standing wave, a wave where the crests and troughs oscillate in place. Traveling wave is actually moving. A standing wave is just going back and forth. Particle velocity is how fast the particles of a wave move in place as they carry a wave. Wave velocity is how fast the crests and troughs of a wave move from one point to another. Reflection, when waves reverse direction upon reaching the end of its medium. And we have diffraction, when a wave tries to turn the corner around a barrier or obstacle.